Now I'd like to return to the Pig Latin example for a moment. The code we have seen previously is over here on the left, where we defined the Pig Latin function to take in a parameter that we called word. The next line of our program was to create a new word, which was meant to be the Pig Latin version of whatever argument is eventually passed to the function. We need to have some mechanism for identifying what that word would be without knowing its precise value, so we call it word. This line establishes the Pig Latin version of the word, and then this version of the function prints the Pig Latin word. Because this function performs a task but does not give a value back to us, this is an example of a void function. When we call the function Pig Latin and then pass it in the argument pig, the printing to the screen that we were seeing originally is happening from inside the function. It's very much possible to rewrite our Pig Latin function as a value returning function instead, which is a little bit more of an adaptable code. For example, our Pig Latin function is sort of pulling double duty. It's both creating the new version of the word, the Pig Latin version, but then it's also making a choice for us, and the choice that this void function is making is seeming to indicate that the only thing we might ever want to do with our word is print it to the screen. If we ever wanted to get our hands on just the Pig Latin version, and then perhaps do something else with it other than print it, this void function would not serve our purposes. We can rewrite this void function a little more easily as a value returning function, where we have the same first line of our function defining the Pig Latin word, but instead of printing the new word, the Pig Latin version, in the body of our function definition, we simply return the Pig Latin word to the user. Now, if our user calls the Pig Latin function, nothing will get printed to the screen unless we explicitly tell the program to print the value that is returned by the Pig Latin function. This may seem like it's more cumbersome, and it is for this particular example, but if we had different uses for our Pig Latin word, where we didn't necessarily want to print it, perhaps we wanted to take two different Pig Latin words and put them together before we printed them, we would be unable to do that with the void function version that we have demonstrated over here on the left, but we would be able to accomplish such a thing with the code that we have over here on the right. So we occasionally have a choice between a void function and a value returning function. Especially in the beginning, it's not always immediately clear to us if we would like to have a void function or a value returning function, but it's easy enough to go between them and alter them to whatever fits your purposes. Let's now just work together some examples of writing simple functions. For this example, I'm going to use the Turtle module so that we have something visual to go along with what we're doing. And let's define a function using the Turtle module that draws a square for us. To start defining our function, we use that reserve word def, and then we need to name our function. Let's name our function draw square, since that's what we will be doing. Because we're drawing a square, and that's a task that needs to be completed, there's no real value to return here. We're going to be defining a void function, and as far as I can tell, there's nothing in particular that I will need to draw a square of a given size. So let's leave it at that for now. We hit enter to start the body of our function, and what we're going to want our turtle to do is move forward a particular amount and then turn by 90 degrees and then do that process 4 times. So we can create a for loop in order to do a particular task 4 times, And the task we want to do is move our turtle forward by some number of units. Let's say 100 for right now. And after completing that, we want our turtle to turn left 90 degrees. That process will complete 4 times, and that defines our draw square function. If we then break the indentation of both the for loop and the function, we return to the main flow of control of our program, and we can call our draw square function and watch it be executed on the screen, like so. Now recall that the purpose of a function is to execute a task perhaps more than once. So let's see if we can create something visually pleasing out of drawing a square many different times. So let's create a variable for the number of times we want this task completed. Let's call it num times, and let's set it equal to something like 35 for now. I'm going to turn my turtle into a very speedy turtle in order for this process to execute in a timely manner. And let's make ourselves a little loop for I in the range of num times. What would we like to do? Well, we'd like to draw our square, so we'll call that function from inside the for loop, and after we've drawn one square, let's have our turtle turn a little bit. And how much do we want it to turn? Well, let's have it turn somewhat uniformly. Let's have it turn 360 degrees, but let's break that up evenly over the number of times we're going to ultimately draw our square. If I run this program now, which executes my draw square function 35 times, well, the turtle was very speedy and it drew this image for us, which is somewhat visually pleasing. Notice that our visual that we've drawn right here is rather large. Maybe we want the ability to control the size of this visual. As it stands right now, the size of the visual is determined by our draw square function. Our turtle is moving forward 100 units uniformly for the square in order to have 4 sides of equal length, which is a good thing, but we have no control over this value. So what's possible is that we could change this function to be a function that doesn't take in any parameters at all, to being a function that takes in one parameter. And let's say that that one parameter is a variable called side length. We could then change this 100 right here to correspond with the parameter of the function, and that would give us greater control over the size of this image. Now, when we call the draw square function, we'll get an error if we attempt to run the program right now without passing in that parameter. Notice that no visual is rendered. If we want that drawing to come back, we'll need to put a value here, and notice that if I put a smaller value than we had before, a priori we had a 100 in here for the side length. Let's see how our image changes when we pass in a value of 50 to the draw square function. Now you can see that we've generated the same image, but it's much smaller.